Okay, how many of you can hear me at the moment? Okay, so if I go close to this place, I'm going to wake people up. No? Okay, so, yeah. Oh, yeah, 1 sec. Because I'm from the computer science department, it's like this, in Finnish we have this saying that suutarin lapsen kengät. So this is going to take a while to get this thing running. So, otetaan tuota. You know, voidaan tästä tuosta. Joo. No niin. Same image, vedetään toi, katsotaan mitä käy. Alright, cheers. So I think we're going to wait for a few minutes to get this Google Docs script responding. Or then we just open the PDF, which actually works. Okay. So, stop script. Quit. Abort ethan. Rules. All right. Go back. That's like a spoiler. Okay, so I think we should first introduce ourselves. Hei, eka tämmönen kysymys. Mä puhun nyt jotain suomea. How many of you didn't have or didn't understand anything that I just said previously? Okay. So jetzt, wir müssen eigentlich die Vorlesung auf Deutsch machen. Ist das gut? Ja, sehr schön. Nee. Eli pidetään varmaan kuitenkin englanniksi, vaikka suuri osa osallistujista ymmärtää suomea. Sitten meillä on, mä tykkään pitää presejä silleen, tai me tykätään pitää presejä silleen, että English. We like to actually keep the presentations so that whenever you have questions, please ask them. I mean, you can just fire away questions as soon as you have some. And we actually have some rewards for your prizes for good questions. So
keep them coming.
Keep them coming. Yeah. So please join us on the stage, or join me on the stage. And this is going to be a bit of Tönkerä English, so don't worry. Okay. So, hi. Who are you?
I'm Emilia, and I come also from the University of Helsinki, as does.
Well, I'm Jouko Strömmer, and well, we're all the same here. And I'll be talking about robots a bit later.
Yeah. All right. So my name is Arto Vihavainen. I also work at the University of Helsinki. I'm there mainly as a teacher, and I'm also working at Linkki, that is like our outreach program that does all sorts of cool things. Like at the moment, how many of you have heard of Assembly MOOC or ASM MOOC? About half. We have to do something about this. Okay, excellent. So, first of all, how many of you are 30 or over? Females, you don't have to raise your hands if you don't want to. Okay, so a couple. Okay, so I'm going to start with. Yeah. Okay. So, when you were young, or when I was young. Oh. No.
I think it was my fault.
What did you? Okay. So. When I was young, I mean, we started computers up so that you booted the computer, you had to wait for a while, and you had this amazing blue screen. And it wasn't actually called the blue screen of death. So it was just, you had a terminal where you could type in information, and actually, because this is done in Google Docs, this one used to be white. So you could actually start the machine, you could code instantly something in, say, for example, this is basic. This is like, okay, the code line 10, print hello world, code line 20, end, run. Yes, like awesomeness would happen. We would actually get everything running, and we'd have a program there. I'll get back to that later, but this was actually really cool. One of the cool things also when we moved forward in programming was that you could actually drop these line numbers away from there. It was like for me it was like a huge moment. Like, what? You don't actually have to put those. What? How does the computer actually know where it should look for? I mean, what line is it on? So something interesting. Of course, when we were playing, it was like, okay, well, first I have to list the games that I have on the disk. Load $8. And then when you'd want to launch the game, for example, you could like load everything or load the game name, and then you'd have to wait for maybe, depending on the machine, depending on the machine, you would have to wait maybe for half an hour or something for the international clarity if you'd be using these cassettes. And later on, we moved to PCs, and we had this command prompt. And this was one of the things I was really fast at typing this, like cd pelit, cd eob, eob.exe. How many of you actually know this EOB, where it comes from? A few. Like, you have missed a lot. That's Eye of the Beholder. It was one of the best dungeon crawlers. It was kind of like Dungeon Master, which is also really awesome. I used to spend hours, actually more like months, playing those games. So also there were actually some programs for learning programming that were designed for kids. How many of you have heard about Logo? Yes. How many of you have studied computer science? Like the same hands. Excellent. Okay, so the basic idea is that you'd have this turtle here. Of course, obviously it's a turtle, even though it looks like a triangle. And you'd have this console on the right where you could actually type in like, okay, right 90. You'd have the turtle turn 90 degrees, forward 100. It would move forward 100 pixels or whatever, and again turn around. And you could actually control the machine without being controlled by the machine. And this is something we get back into later on when we go into some of the current programming education tools. So what actually happened there, some like 20 years ago, 10 years ago even, computers actually booted to command line interfaces. We could really start doing something. Well, yeah, I actually told this already, but it took half an hour to load International Karate Plus, and it didn't even always work. Like, you'd wait for half an hour, wondering like, okay, what's wrong with this machine? Like, why is it so slow? And really like having to ponder what's going on inside the machine if you didn't have those Donald Duck magazines with you. And one of the big things was that nuts and bolts, which basically like the engine, everything was visible, and you could actually just try what was going on if you type something crazy, press some buttons. It wouldn't break up. Whoa. Okay. And on the other hand, we have modern age. These days, when you boot up a computer, of course, fortunately, we don't actually go this far yet, that when you boot up a computer, you boot to Facebook. But how many of you are thinking about that as one of the possible futures? Like foley hats. Okay, nice. Yeah, but yeah, we have basically games that you can launch up by just double-clicking something. Everything is there. You use the machine with a mouse or your fingers, like Nokia. Rest in peace. No, actually, I'm honestly hoping that they'll rise from the ashes. And basically what you have like graphical UIs where everything there is there. You just have to use the UI with your finger and you get to games and whatever you want to play, which is completely different from what happened some like 20 or 20 years ago. So these days, computers work out of the box. You can launch programs and games directly without having to actually worry about anything like, okay, well, does my machine, is the like the buffer memory, is there enough stuff there? I don't know. And when you retrieve new software, when we were younger, it was like, okay, I have to use this Xcopy program to copy that disk from another, or like a 2-deck cassette player. Oh, okay. No one did that. It was illegal even then. And then basically retrieving software these days, it's basically just you enter a store or go online, click something or like say, okay, this looks cool, take it to the counter and buy it. You install it, you click it maybe twice and you get to play. It's like, okay, so where's the difficulty? Like, I don't know, maybe I should move this a bit. But basically what happens is that even untrained monkeys can do this stuff. It's not something where you have to actually get into the hard parts where you have to wonder what's going on inside the machine. It's just there. It's like milk. I mean, like 20 years ago, okay, more than 20 years ago, if you'd want milk, you'd have to like find a cow and hit it to like hold it, strangle it to keep it in place. Like, and once it's choked out, you'd go to the titties and start getting some milk. These days, you just go to the store and like, okay, luomumaito, put it to the cart and it's there. Okay. So one of the problems that we see is that there aren't that many challenges anymore in computers. I mean, for kids that start using computers, it's like, okay, it booted up, double click, oh, Facebook, cool, Farmville, something, games. So there isn't anymore like this reason to dig deeper. No one has to actually dig deeper into the games or what's going on if they don't want to. And we don't have that built-in problem-based learning environment. I mean, basically before, when you had this computer that just launched up to like this blue screen with this white rectangle blinking there, or actually I don't think, was the Commodore 64 CLI, was it blinking? Like, yeah, okay, anyway. So you were like, if you'd boot up there, you'd be like, okay, so what's going on? I have to learn something. These days it's like, okay, well, there's something, I have this thing in my hand, click, click, oh, game started up. Okay. And on the other hand, new ideas and innovation, they actually come from challenges and existing background, but it's basically knowledge on what's going on in the machines, what's going on inside the games, what's going on in the environment. So we have to do something about it. Okay? On the other hand, there is always this question, okay, I don't care. Why should we care? This is something that's not that important, maybe. On the other hand, how many of you have heard, I mean, I noticed earlier that there are quite a few people that are under 30. How many of you have had this moment where you're like cousin or grandpa or uncle or someone calls you like, hi, my machine is broken, can you fix it? Yeah. What's actually going on is that people assume that you're diginatives. They assume that, okay, if you're young, you can do stuff with computers. And that's not actually always true. It's actually pretty seldom true. Maybe we're kind of like the group that is sitting there, or you guys. You might be slightly out of the normal average people that are living on the outside world. But anyway, so there aren't that many people that actually know what's going on there. On the other hand, technology actually plays a huge role in our lives, so we should understand what's going on, even without something. I lost my train of thought. Now it's a good time for a question. Anyone? No? It's like I have to eat all these candies myself. Okay. Anyway, so what's going on these days is that everyone has a mobile phone. You have at least one operating system with you all the time. Everything runs on computers. All the banks, everything publishing, whatever. Those guys there in the background. Hi. It's like they have like a huge bunch of computers there editing the video out and looking what's going on. And if no one actually knows what's going on in the background, we might end up in a interesting situation. So the big brother is watching you, and no one actually knows about it. Okay. How many of you actually have heard or read the Orwell's 1984? Okay, if you haven't, you have to check it out. It's really cool. Okay, so what's going on these days is that participating in the society actually requires you to have a set of media and technology related skills. Actually require understanding from computers and what's going on in there. We don't have classes in schools that actually educate younger people about, well, media and technology in general. We claim that these skills, or technology-related skills, actually reduce marginalization. Basically, today, if you want to have a job, you have to be able to work with computers. And okay, often these skills are learned in collaboration with others, and in the end, they also protect you from getting fooled by the media and the world, like this folio hat thingy. But actually, if you really look at all these like scam mails that are arriving at people's inboxes, if you always believe what's going on in the internet, you'll end up in a bad situation. All right. So, what actually we're working on as Link is we're trying to move the generation or the youth away from being just consumers into understanders, again into producers. And one of the big questions for us is how do we actually do it? I mean, if you have a kid that's like looking at you with some AS in his hand and playing World of Warcraft, how can we actually move him away from that area into maybe understanding extra and doing something, giving some output to the world? Okay. Of course, starting is harder than it used to be, as the nuts and bolts are hidden from the user. I mean, this is actually a pretty cool example. I mean, you have Windows installation screen. Here is like this, enter your product code here. And then if you don't put it there, do you want to enter your product code now? Like, you have a lot of like stuff on top of the systems that are going on. But on the other hand, it is starting to understand computers can be easy if you know where to start. So you have to also help others. So one of the examples is Scratch. How many of you have heard of Scratch? Okay, how many of you have heard of Scratch before reading the abstract of this presentation? Okay, actually, what more guys raised their hands? Like, what was it when I said Scratch there? Okay, yeah. So let's take a short look at Scratch. It's actually a system. There are actually online versions for this that especially I heard today about. One of you can raise your hand like, woo! No, you have to do it. Okay. I mean, there are a lot of cool people that are working on visual programming tools for children. And what is this? Scratch is basically, it's a visual programming tool where you have a set of commands or instructions that you can give to the game character. You basically program it using scripts, and then you can get the character to do whatever, like movement. Emilia, do you want to? Let's have a demo.
Yes, of course.
Yes.
Step away from the keyboard.
Thanks. Okay.
So good morning, everybody. My name is Emilia, and I'm showing you now how to use Scratch. Scratch is a visual programming tool that is created in Massachusetts University of Technology. And actually it works like we have the cat. If you don't like cats, you can change the character. So there are pre-made characters like unicorns, which are my favorites. And on the other hand, you can also draw a character yourself and then use it in your game or in your show. Okay, Arto is drawing right now. So this is a really cool character. Can you draw a little bit quicker?
Yes, sorry.
Yeah.
Okay,
And
so
in
I'll
the middle
kill
part
the cat.
of the program, we see area for scripts. And actually, scripts are these Lego-like blocks here. They're called scripts. And we can get the character to do something by taking some of these blocks into the middle area just by dragging them with mouse. Okay. And there are blocks like, for example, move 10 steps.
Abort Ethan.
Demo effect.
Obviously, this hasn't been done by us. Okay. One more. Yes, it's very easy to use.
As you can see.
Okay.
But
so
basically the thing is that
I'll
you
kill this
create
program.
blocks of these small blocks, like click them together into bigger blocks. And actually the program is designed so that all these blocks resemble real programming structures. There are like if structures, different kinds of loops. You can do something 10 times, you can do something forever. We can, for example, put the cat going around by telling it to move 10 steps and turn 15 degrees forever. So it just keeps repeating those commands. And actually you can do really complicated stuff with the program. You can, for example, design games that have lots of different characters that can interact with each other. There are like sensor blocks that you can sense that if some other character is touching your character, and then based on that information you can do something.
Yes.
Question?
Yes, you can. No, wait.
No, you can't actually.
At this stage, yes.
At this stage, yeah.
There you go.
But it's a program that is in development constantly, so there.
Yeah, quite a few.
And there have been really many new features for the program, so don't know what's coming next up.
Yeah, but you can also mod it. It's open source, so you can add your own blocks. And actually,
the cool thing about Scratch is that first, it's completely free. Second, it's designed to keep in mind that people don't always have really good computers or don't have so much money, so that it's free, and then it's available for all the 3 major operating systems, for Windows, for Mac OS X, and for Linux, so that most of the people could just download it and getting to use it and to teach others to use it.
Yeah, into making games.
Yeah.
Yes. I have to show you guys something. This hasn't been planned. Maybe it was. So actually, this one guy, I asked his father for permission. This is from Elias Huttunen. We actually, as Link, we organize game programming camps for kids. He's 8 years old, and I'm hoping this will work. It's not about his program, it's about the... Yes, all right. Nope, we're missing the background. Okay. Maybe you can tell something.
Yeah, we can actually showcase these games that were made by children this summer in our game programming camps, which were actually a really huge success. We did those together with the youth department in Helsinki City, and we actually got twice as many applications for the camps that we could take in. So hopefully next summer we will be organizing more summer camps, and actually we're organizing at the moment during autumn and spring a weekly game programming club at the University of Helsinki. So if you know any children that are interested in learning to make own games and do all kinds of cool stuff with computer science, take our address down and see how to apply for the club.
Yeah. So basically what we were trying to demonstrate to you was, how many of you remember the game called Slicks and Slide? Oh yes. What happened, we actually showed those kids like, okay, this is Slicks and Slide, and it was done by this and this company and so on. And at third day or fourth day of the week, we spent some time on discussing how it could be actually done using Scratch. And most of the kids, I mean, Elias is 8. I can demonstrate his game later on when this machine starts working. So if you come to talk to us, we'll show it. He's 8, and he was able to make a game where you can control. Actually, I think it's a tortoise or something, or octopus with your keyboard. It has velocity, so if you press up, it starts moving. Then you have to control it with right and left arrows. And if you get out of the screen, you get back to the starting position. And actually, it counts laps as well. It's like, for an 8-year-old kid, I'm like, okay, what have I been doing for my youth? I could be like at the top at the moment. Yeah. All right. So this is one of the really amazing tools for. Yes. Gender balance is unfortunately still slightly skewed. Yeah. In numbers, I would. Yes, we have.
Yes.
Actually, no. Yeah. We have actually we have more than just one.
Yeah. In the first summer camp, I think we had 5 girls and 25 boys. So I think it's about the same that here in the Assembly Festival and actually in computer science department at the University of Helsinki, where we come from.
Yeah.
But we're hoping to work on that also.
Yeah, because actually there's a lot more in games than just like programming and stuff. Because there's a lot of things to do with arts, with music. For example, last summer, not this summer, but the summer before, we had one person like coming in with a A4 paper, like, okay, I drew this background. Can I use it for my game? Absolutely. Hey, I have composed this music. Or actually, no, I think her sister had composed it. Yeah, okay.
Her big sister.
Yeah. Hey, my big sister has composed this song. Can I use it for my game? Absolutely, you can. I mean, it's you can just whatever you have, you can take it in. So it's really cool.
I think that the big point is that many people think that, especially small children and under 12-year-olds, that technology is something boring, and it's something with maybe ones and zeros, or putting things together, and it's really technical and it's boy stuff, but it's not true.
Yeah, it's like robots with swords, like fighting each other.
But it can also be like glitter and unicorns and whatever actually you like it to be.
Yeah. Hey, question.
Yeah, actually, yes, this what you show is in English. Is the Finnish version for the small children?
Yeah,
yes,
of
yes.
course.
Actually,
you can have this program in many other languages as well. We've been using it in Finnish when we're having our clubs, but actually when we were having school visits, which I talk about later, we used it also during English class, because an English teacher came with a group of her students to us and asked that could we have this workshop in English, because they're having an English lesson. So we immediately just changed the language of the program to English and then started giving directions in English.
Yeah.
And actually both the students and the teacher were really thrilled.
Yeah, and of course when they had questions, we were like, okay, what? I don't understand. What is that language you're talking with? What? Is it Finnish? No. What? I'm from England. I don't understand anything. So, so a lot of fun. Yeah, you can also have a Swedish version, and there is also like Swahili and all really interesting languages around. Okay,
There's
so
a question.
oh yeah, yes, yes.
Yeah, thanks. Yeah, I just want to know what are the age limits in your courses?
Age limits.
Age limits, yeah.
We don't actually at the moment have any, but the youngest I think is 9 years old, and the oldest might
no.
be 15 years old.
8. Actually, in the fall course, it's 9, but the youngest this summer was 8, so I think 8 is also fine. So it's,
I
mean,
think that if you can manage with other people and can read, they are like the basic requirements, because it's hard to use this program if you can't read what the blocks say.
yeah, and
But
it's
that's the minimum.
basically when you introduce kids to new stuff, it's more about participating and like being with adults, discussing with them, and saying like being interested really what they are doing. So
And actually that leads us to our next bigger
Age.
topic. Yeah.
yeah, so you can talk.
Yeah. So this is the school visit thing I talked about earlier. We had this problem where Finnish educational curriculum doesn't actually have at the moment almost any classes that handle information technology or computers, or where people could discuss and learn new things, so that when kids are taught about computers, it's like they write essays on Word and nobody maybe really teaches them to use it. So that we wanted to make technology available for children in schools, and also give their teachers tools to organize classes. And then we went together with the Finnish educational department,
Yeah.
opetusvirasto in Finnish, and with the Helsinki City Youth Department, which what I was talking about earlier. And then we had this Innostu teaser tour in 3 schools in Helsinki area, where we came into the school for a day and showcased. We had these workshops where children could do their own game characters with play-doh and paper and pen, and then come to us and put it into computer with Scratch and draw that there, and then started to design their own games. And in 2 or 3 schools we had also the robots with us, and both the children and the teachers were really thrilled. And the big thing was that we wanted to show the teachers, because they have of course, they think that it's really hard, and I'm so old, and I don't have education for this, and I cannot do this. But it's not true, and I think they got that really well during those workshop days. And we also wanted to show the kids that actually you can do really cool stuff in school, and actually you don't have to just play games that other people have designed. You can also be the designer for yourself. And we don't know where this leads us, because this happened during this spring, but we are having a really good response from all the 3 schools, and we are continuing with some events in the future as well.
Yeah.
So keep tuned if you're
And
interested.
actually, the cool thing is that Opetusvirasto, or the Finnish Educational Department, they're kind of like, because we're creating some grass level movement. They're like pushing the school directors from above. So they had a meeting, I think, a few weeks back, and they were like, these school directors that were discussing with each other, like, okay, hey, this day was really cool. So we have already some extra movement going on around that. Hopefully in a few years we'll have a
mandatory technology for everybody.
yeah. Yeah. So
Actually this slide is what I told about earlier, that we had these English classes where we used Scratch in English to teach how to make your own games. But then we actually had also visual arts teachers coming, and of course creating with Play-Doh and drawing your own characters is a really good visual arts educational thing, and we got also math teachers to introduce their students with Scratch. You can actually do many kinds of mathematical stuff because there's a XY grid in the back of the characters, so you can teach, for example, X and Y points and how to calculate which kind of movement the character makes.
Yeah.
There's a question.
Oh.
Yeah, question. Or not quite a question, but I just wanted to say that I just saw a video clip of Valve doing kind of the same thing with the Portal engine. They were, there was a class of children that went to the Valve like studios, and they were like playing around in Portal, and they were like trying to teach the kids physics and science and tech.
Yeah.
And they were like, okay, let's demonstrate an oscillator. Like they made 2 portals on the ground and dropped a block that would go down, up, down, up. Okay, that's an oscillator, and then they would like demonstrate the concept. So I just wanted to say that Valve is also doing. They had a really cool video on that.
Really awesome stuff. I have checked that out because it wasn't a question. You got the Lätkäliiga.
Okay, awesome.
Come and talk to us later.
Yeah. So basically, the both teachers and students are really thrilled about this, and we're hoping to get more movement in that area as well. This, of course, it's in Finnish, but we had a lot of good feedback. I mean, all of these are like favorite games and feedback. So basically, I'm not sure about this whether it's a smiley or a sad face because it has like both arcs going up and down. All others are like all smileys. We were like having visual feedback from each school.
Yeah, we were asked the children to give us smiley faces or sad faces depending on did they like the workshop or not, and we got almost all smiley faces from every school.
Yeah, and then there were some duck faces as well. Yeah. Okay, so then we have a small set about programming robots because that's one of the...
There's a question.
Yes. Sorry?
So would this material be available somewhere?
The class material or the slides?
Instructions. The instructions how to make this kind of presentations or events?
Hopefully in the future, yes. At the moment we have in Finnish in the internet all the material we used in children's game programming camps, summer camps this summer. There are different kinds of guides how to use GIMP, the image editor program, and how to do slicks and slides types of games with Scratch. So we can give the links you later.
Yeah. Nice. All right. So next we have Yoga or Jouko, and maybe Joel as well. I don't know if he's coming on stage.
And they will be telling you about the use of Lego Mindstorm's robotic kits in teaching.
Yeah.
So welcome.
Yeah, good morning.
And here's your microphone. Okay, good.
Can you hear me? All right, I'll touch your behind.
My behind.
Where is the thing?
It's there. It should be on.
Okay.
Oh, nice. So, to recap, I'm Jouko Strömmer, and I've been teaching robotics courses in Helsinki and once in Jyväskylä actually. Yeah. And this is not my day job really, but it's fun. So, our CS department purchased a big quantity of these sets because we wanted to give each student their own set and not borrow, say, 5 sets or something, because it's difficult to make robots if you always have to dismantle it and give it to someone else and then do it again. So we've had robots before, but this is the first time we have enough of these, and they're designed to make some cool robots. We used to have Roombas and stuff like that, but they require deep understanding of many things, and it's not as accessible as the Legos. Well, you can see here the specs. It's a fairly versatile kit. It has 3 servo motors, 4 sensors, and well, the sensors vary slightly. There's a newer version of this set, and hundreds of pieces of Technic Legos for assembling the hull of the robot. And also it has Bluetooth, so we can use other devices like GPS receivers or just simple serial port communication. We can use an auxiliary computer to, well, for using OpenCV, for example, and give the robot computer vision. And of course, Legos are fun, and they're familiar to, well, almost anyone who's ever used them. And these are fairly good reasons to use the NXT. There are, of course, other robotic sets, but this is fairly popular in education. And here you can see the techie stuff. As you can see, it's fairly powerful. It is a 48 megahertz CPU, and this 8-bit AVR is for lower level auxiliary functions. And as we are in assembly, you can see it has 64K of RAM, which is plenty. And the thing that's not talked about much is that the NXT is open source hardware. Actually, I can show you what it's about. This is the NXT. I'm not sure if it shows on camera, but you might have seen these at our workshop also. But the point about open source hardware, actually the firmware is replaceable, the source code is available, there are circuit schematics, it's really open. They don't market it as such, I don't know why, but it's a good point. And it ships with this NXT-G, which is mostly for kids. It's a bit like the Scratch here, but a bit different. So you can visually arrange your program, and you don't have to type much code, maybe some small blocks. But we don't use it at our department because we use this as like a programming project course where the students first learn usually Java, and we know that they, at this point, they know Java, so we give them a programming project, and they can pick if they want to do it with a robot or with traditional software. And there's, you can use pretty much any language you want. We use Java because the library is really good. It has a lot of functions, and it's also a firmware replacement, so it actually runs the JVM on the NXT block itself. Also, I hear the Lua library is really good, and it's, I think it also compiles and executes it on the block, or the brick. So the course we have, it's about we give each student a kit of an NXT kit, and we don't give them many set goals or, well, a subject. They have to pick their own subject. It's like a traditional programming exercise where you implement something. It might be a, well, a game or simulation or just some algorithm. But in this case, since we have the robots, and I would like to add to the previous point of making things accessible, when you boot up your C64, you see the programming interface, and you can just do it. And with the robots, it's a bit different because we're in the physical realm. And but it's still easy. I mean, I can take this thing and turn these wheels, and I can figure it out without knowing much about what's going on inside. But I can make it do what I want. And it's easy to kind of grasp and look at, and it's kind of obvious. But for example, if you're working with pure code, there's a lot of things you have to know first. With the Lego like this, you can see if it doesn't have the space to turn or something like this. But if your program crashes because there's some buffer overflow somewhere, you have to go deep. Of course, I'm not saying that these are always easy to program, but usually they are. So we give them a robot, then they play around with it, they take it home, and usually it takes some time to get used to it and to kind of find out how powerful the servos are, how the sensors work, and there's a lot of getting used to, and it's only a 6-week course, so a couple of weeks goes with experimenting mostly. But there are some, you could do just about anything with these. There's some topics here you see. There's robots that solve labyrinths. They could play tic-tac-toe or, well, just about automate anything you want that requires either physical input or sensory data and some manipulation of physical reality with the motors. But there's a slight problem when you teach or use robots for teaching, which is that it's fairly complex. It may be fairly complex to set up your IDE and the programming environment and to just get used to it. And there's flashing the firmware on it and Bluetooth and a lot of configuration. But what we do currently is that we have something called Robots. It's just a remastered Ubuntu system that we can run from a USB stick on any computer. So this speeds up the course a lot because the first course is, I think the first 2 weeks or even 3 weeks, I had to help tens of students with their operating system and configuration and type this into the terminal and stuff. And there were a wide variety of problems because some people have Mac OS and some people use Windows and some people use something totally different. So we wanted to give something that we can guarantee that it should work with this. And this actually works really well. And after we started using this, there have been not much problems. It's just a few minor ones or with the booting or something. But after that, it's ready. And for example, we had these workshop activities. For example, here also we have, after this seminar, there's a robotics workshop, and you should come there. And you'll see how this works. You get to build your robot and write some code. And also, yeah, you don't have to worry if you're using it, so because it's a self-contained system. But do you have any questions at this point? Nope. Okay, I'll show you some examples. Here's a printer, and these are quite popular. There's many ways to do them. You can see that the NXT rig is powering 3 servo motors. One is rolling the paper back and forth with these 2 rubber wheels. The second one is rolling the print head along the other axis. And then there's the third servo motor that I guess it lowers the pen. I can see the tip there. But you could also use some drum that you roll and write on it. There's so many possibilities. It's usually just hard to pick your subject. And here's a dancing penguin. I don't recall the specifics of this robot, but I think that's my hand there. I'm not sure. But you can see it has 2 servos on the behind. It probably wiggles its legs somehow. And I think there might be a third motor back there to move its beak, or I'm not sure what penguins have actually. And there's the ultrasonic sensor that can sense the distance. So I think that if you walk there, it probably says something to you, maybe. And there's a microphone, so you can give voice commands, or at least yell at it. And here's an interesting one. This was made by a student in Jyväskylä. It's a sort of a tower. Well, you can figure it out what it does. It's a panoramic camera, so it takes pictures at fixed steps and rotates and spirals upwards. And then there's the software that combines the image into a nice panoramic picture. And there are a lot of many things. For example, right now this is a simple car, but we can use the sensor here to make it not bump into walls. We can program it so that when it sees that there's only 20 centimeters of space, turn around, drive, and it's just about your imagination, what you want to do. I'm not sure what this is. Oh, yeah, I think this is some sort of gripper. Well, I won't be turning it now because the servers won't like it, maybe. But you can see more of these robots at our workshop downstairs. Starting now, right? I guess I'm over time then. All right, well, thanks.
Yeah. We're actually slightly over time, so sorry about that. But the last thing
we won't be leaving you until this is over.
we won't be leaving you without this. So the last thing that we have to talk about is MOOC. How many of you have heard about MOOC without the awesome prefix? Okay, so basically it's an open programming course that is available for everyone. So why
because
we did this?
This is about making technology mandatory for everybody. We can start, because we're the University of Helsinki, we can start the thing here now in schools, but that takes time, and actually, for example, people in Rovaniemi don't get much out of that. We're making robot classes for people in schools in Helsinki, so we introduced this MOOC.
Yeah. So basically, yes, no, yeah. No, anyway, you guys, if you can't hear me, I can give you candies later on. So, yeah, the problem also is that a lot of the teachers don't have enough skills to give classes. So we actually created a course that is free for all, and it's designed to support the actual programming process. So when you have a well-done material, I'm one of the authors, and it has exercise embedded into it. So you have to read the material a bit. You encounter an exercise, and you have to solve it. We have built a tool for programming. It's actually a NetBeans plugin. So you can program it. You can program the exercise, and the plugin actually supports you in the programming process. So if you're lacking some, let's say, some class definitions or something, it's going to say that, okay, well, in this exercise you were supposed to do this, but you didn't do it. And one of the cool things is that the MOOC course is formally acknowledged by us, by Helsinki University, which means that secondary schools, because they have formal acknowledgement from us, they can use it in their curricula for free, and they can actually give credits without actually worrying whether it's real or not. For us, it's one of the cool things is that it actually works as a prolonged university entrance exam. And if you can beat over 377 programming exercises during a spring, you'll get invited to like an interview, and there's an option for getting into the university directly. And we're going to do a first elementary school iteration in spring 2013. There are already elementary schools that are interested about this, and it's like we're really, really thrilled about this.
And
So,
the super cool thing is that we have actually the assembly version of the course going on now. So you should all check out the website asm.mooc.fi, and there's a cool competition. When you sign up and start doing exercises, the more exercises you do, the more points you get, and all the points go into lottery, where you can win a 600 euro Asus
NVIDIA GeForce GTX 680, and some gaming mice and stuff
and
like
some
that.
other cool
Yeah.
prizes as well.
Yeah.
But if you got any relatives, friends that might be into programming, but they don't know where to start, or they want to try, show them the website and get them to do some exercises and see if it's for them or not.
Yeah. All right. Of course, this hasn't been done by just the three of us, this whole stuff. So there are a lot of people behind. We had people from of course, Opetusvirasto, Forum Virium, Pelitalo, Happi, Lumakeskus, and well, Linki. So it's a lot of huge thanks go to all of those, and of course to you guys for coming to watch us, or maybe the next presentation. Sorry for overlapping a bit. So, any questions? And thank you a lot for coming to watch us. Any questions? No? Then a huge applause for you guys.
Thank
Okay.
you very much
Thank you very
for
much.
listening us. And for those of you who want, we do have the robot programming workshop going on now downstairs in the Pelitalo stand. You can find it in Karjala restaurant, and we will be going there as well. So please join us and see the robots in action and maybe try them yourself. Thank you very much.
Yeah. Thank you very much.